Welcome to Study Loop.
This is the answer to Chapter 21, problem number 78 from the Smith Organic Chemistry textbook. And this problem actually asks us quite a bit. So it's in three parts, A, B, and C. We'll take them one at a time. So part A says, explain how sodium borohydride in methanol can reduce hemiacetal A to 1,4-butanediol. All right, so to start, I will draw hemiacetal A. So here's hemiacetal A. And we're asked to explain how sodium borohydride in methanol can reduce A to 1,4-butanediol. And so the answer to that is that this hemiacetal is also, not also, it's in equilibrium with its acyclic hydroxyaldehyde. So I believe that this was covered somewhat in the part of the chapter that talked about glucose. And so there's an equilibrium here between the closed ring form of this molecule and this form of this molecule. Let me just count carbons. 1, 2, 3. Okay. And this form of this molecule, where it's the aldehyde. And so when it's this opened form of the aldehyde, obviously sodium borohydride and methanol can reduce an aldehyde. That's pretty much what it does. So sodium borohydride and methanol can reduce that aldehyde 2, 3, 4 alcohol to 1,4-butanediol. So that's the answer to part A of this problem. Okay, so moving on to part B. So part B asks us, what product is formed when A is treated with this Wittig reagent? So, okay, so this is going to be the same kind of thing, right? So, again, this is A. So, cyclic hemiacetal, but again, A is in equilibrium with this opened chain hydroxyaldehyde. 1, 2, 3, 4. Okay. And so obviously this reaction can happen at the aldehyde here with the Wittig. And so the Wittig that we were told to use is going to be this one. 3. So we're told to use this Wittig here. And so that is going to just join these two molecules together in typical Wittig reaction fashion. So let's see here. So that's going to give us CH3, CH2, CH2, CH. So that's the portion of the molecule that came from the Wittig reagent, and then the portion of the molecule that came from our starting hydroxyaldehyde is going to be CH2, 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 OH. So just to clarify here, so this part came from the Wittig reagent, and this part came from our hydroxyaldehyde. Okay, and part C, I will also give its own page. So here's part C. What does part C ask? Oh, so part C is asking us to make Accutane. Accutane isoretinoin is formed by a reaction of X and Y. What is the structure of isoretinoin? Um, okay, yeah. So the actual question that we're asked here is what is the structure of isoretinoin? And so looking at what we're given in this problem, we're given another um, hemiacetal type molecule, another molecule basically that can open to, well, so this one's going to open to a carboxylic acid and an aldehyde. And so that aldehyde can undergo Wittig reaction. And then, so that accounts for X. So then part Y of this molecule is all set to be made into a Wittig reagent. And this, I guess, might be a little confusing since up to here, the book has insisted on using butyl lithium to form Wittig reagents, but for this problem, it's going to go ahead and use sodium ethoxide. Sodium ethoxide in this problem is going to do exactly the same as the butyl lithium would, and so it's just going to form the Wittig reagent there from Y. And so I will go ahead and just draw everything that I just said. I suppose I could have been drawing it as I said it. Right. Okay, so here's X. And just as in parts A and B, um, although X is a little different than molecule A that we used in those parts, really it's the same. And so this is going to open also into its sort of open chain version, which is going to look like this. Oh, oh yeah, no, okay, that's right. Okay, and so the carboxylic acid there. So this aldehyde here is suitable for reaction with a Wittig reagent now. And then we'll look at Y. And so Y is going to look like this. With a positive charge there. And so again, all that the sodium methoxide is going to do is going to be to act as a strong base in much the same way as butyl lithium has in every other Wittig problem that you've seen so far. For some reason, they chose to change it up this time. I guess probably because in industry, when this molecule was made, um, lithium is well, sodium's a metal too. I don't know. For whatever reason, they probably wanted to avoid butyl lithium and use sodium ethoxide instead. Um, Maybe because sodium ethoxide is a solid, butyl lithium is has to be in a liquid. For whatever reason. So PPH3. So there's our Wittig reagent. And so the Wittig reagent that we made from Y and the aldehyde that can be made when X opens up are going to react. And so if we draw the product of what that Wittig reaction would look like, we will get the answer that they're looking for part C as to what is the structure of Accutane. Okay. Yeah, and so the double bond that results from the Wittig reaction could be cis or trans. Cis is going to be more stable, or pardon me, trans is going to be more stable. And so I've drawn it as trans. Of course, doing it this way without any type of control would result in a mixture of cis and trans. But trans is going to be more stable. So as I said, I just drew it as trans. Yeah, and so that's the structure of Accutane there. That's the answer to part C. And overall, that's the answer to chapter 21, problem number 78.